We can also solve for geometric means. The terms placed between two non-consecutive terms of a geometric sequence, just like arithmetic, are called geometric means, where if I went from 5 for my first term to 40 as my last term, then 10 and 20 are geometric means. They're going to multiply by the same thing to get from term to term to term. So if it says insert 4 geometric means between 81 and 1 over 792, then I'm going to have my first term be 81. I need to insert 4 terms in between 1, 2, 3, 4. And then my last term is going to be 1 over 729. Now, if this is true, and we said that this was term 1, term 2, term 3, term 4, term 5, and term 6, then term 6 would equal term 1 times r to the power of 6 minus 1. Or my value of term 6, 1 over 729, would equal my term 1, which was 81, times my r value, which I don't know, to the power of 5. Now, how would we actually solve for r? In order to isolate r, I would divide both sides by term 1. So I'm going to say that r to the 5 is equal to term 6 divided by term 1, or 1 over 729 divided by 81, and then to get r, I would need to take the 5th root of that. So r is going to equal the 5th root of 1 over 729 divided by 81. This means that my r value is going to be 1 over 9. If I know that r is 1 over 9, I can fill in these missing terms by multiplying by 1 over 9 each time. 81 times 1 over 9 is 9, times 1 over 9 is 1, times 1 over 9 is 1 over 9, times 1 over 9 is 1 over 81, and then times 1 over 9 again is 1 over 729. Well, how did this r value work? In order to solve the r value, I took the value of the later term divided by the value of the earlier term, and I had to take, to figure out how many changes occurred in between them, the q minus p root there. To get from term 1 to term 6, there was 5 changes, or 6 minus 5. That's what tells me the index. And then I just take the value of the later term divided by the value of the earlier term. And if my terms are not right next to each other, there's a formula that I can use to always find what my common ratio is. If it says 3 consecutive terms of a geometric sequence are x plus 3, x, and x minus 5, then because I know that a common ratio never changes, where it'd be term 2 divided by term 1 is equal to term 3 divided by term 2, then I can apply that and say that if I take term 2 divided by term 1, that has to be the same as term 3 divided by term 2. I'm going to multiply my x into both sides to get rid of that denominator. I'm going to multiply my x plus 3 into both sides to get rid of that denominator. And then I can say that x squared would equal x squared minus 2x minus 15. When I take away an x squared from each side, now I just have a linear equation I can solve. 0 is equal to negative 2x minus 15, which means that 2x is equal to negative 15, and x is equal to negative 15 over 2. If I know that's true, I can use that to solve the first 3 terms. Term 1 is negative 15 over 2 plus 3, or negative 9 over 2. Term 2 is just x, so it's just negative 15 over 2. And term 3 is going to be negative 15 over 2 minus 5, which is going to give me negative 25 over 2. So my geometric sequence is negative 9 over 2, negative 15 over 2, and negative 25 over 2. Now, if I divide these out, I could always prove that this works because I could find what the common ratio is if I divide one term from the next, and every single time I'm multiplying by 3 over 5. Last example, the 4th term and 7th term of a geometric sequence are negative 54 and 1,458. It wants us to determine the first term and the common ratio. Well, we already know how to do a common ratio. The common ratio is going to equal the 7 minus 4 root of term 7 divided by term 4, which means that the common ratio is going to equal the cube root of 1,458 divided by negative 54. This gives me a common ratio of negative 3. if I know that Tn is equal to T1 times R to the power of n minus 1, I can use either of these to solve my Tn. I'm going to say that, or sorry, my T1. I'm going to say that if negative 54 is equal to T1 multiplied by my common ratio of negative 3 to the power of 4 minus 1, then to isolate T1, I'm going to divide that 3 to the power of 4 minus 1, or 3 to the power of 3 from each side. Negative 54 divided by negative 3 to the power of 3. And that's going to give me a T1 of 2. So I can say that my general term is going to equal 2 times negative 3 to the power of n minus 1. And that's it. Go ahead and get some practice.